Welcome to Tech Academy Labs, where we simplify complex tech topics. Today, we're diving deep into one of the foundational concepts of computer networking, network topologies. Whether you're preparing for the CompTIA A+ exam or just looking to understand how networks are structured, you're in the right place. So, let's get started. Before we explore the different types of topologies, let's first understand what a network topology is. A network topology refers to the physical or logical arrangement of network devices and how they are interconnected. Essentially, it defines the structure of a network, how nodes, cables, and devices like switches and routers are organized. There are two main types of topologies. Physical topology refers to the actual physical layout of cables, devices, and connections. Logical topology deals with how data flows within the network, regardless of its physical layout. The choice of topology can affect performance, scalability, and even the security of a network. Each type of topology comes with its own advantages and disadvantages, which we'll discuss as we go through the most common ones. Let's now dive into the most common network topologies. Bus topology, ring topology, star topology, mesh topology, tree topology, and hybrid topology. Each of these topologies has its own unique characteristics and applications. Understanding these topologies is crucial for designing efficient networks. Let's start with one of the simplest topologies, the bus topology. Bus topology uses a single central cable, known as the backbone, to connect all the devices in a network. Each device is connected to this cable through a T-connector. Data sent by one device travels along the bus in both directions until it reaches the intended recipient. Advantages: cost-effective. Since it requires less cabling, it's relatively inexpensive to set up. Simple to implement. Especially for small networks, it's easy to understand and manage. Disadvantages: limited scalability. The more devices added, the slower the network becomes due to data collisions. Single point of failure. If the main cable or backbone fails, the entire network goes down. Difficult troubleshooting. Identifying where a failure occurred can be challenging, especially in larger networks. Bus topology was widely used in the early days of networking for smaller LANs, local area networks, but it has largely been replaced by more efficient topologies due to its limitations. Next, we have the ring topology. In a ring topology, devices are connected in a circular fashion. Each device has exactly two neighbors, forming a closed loop. Data travels around the ring in one direction, or sometimes both, in a dual ring topology. Advantages: equal access. Each device has equal access to the network, which can reduce data collisions. Efficient for smaller networks. It performs well in small to medium-sized networks with controlled traffic. Disadvantages: single point of failure. Like the bus topology, if one device or connection in the ring fails, the entire network can be affected. However, some ring networks use a dual ring setup for redundancy. Latency issues. As the network grows, latency increases since data must travel through multiple devices to reach its destination. Use case. Although not as popular anymore, ring topology is still used in some fiber optic networks and metropolitan area networks, where traffic control and data collision minimization are critical. Now let's talk about the most widely used topology today, the star topology. In a star topology, all devices are connected to a central hub, switch, or router. The hub acts as a controller, managing data flow between the devices. Advantages: centralized control. The central hub makes it easier to manage and troubleshoot the network. Scalability. Adding or removing devices is straightforward. Just connect or disconnect them from the hub. Failure isolation. If one device or its cable fails, it doesn't affect the rest of the network. Disadvantages. Hub failure. The central hub is a single point of failure. If it goes down, the entire network is affected. Cabling costs. Since each device requires a separate cable to connect to the hub, the amount of cabling required can be high in larger networks. Use case star topology is most commonly used in modern LANs due to its simplicity and reliability. Wi-Fi networks also follow a logical star topology, where all devices communicate through a central access point. Now we move on to the mesh topology. In a mesh topology, every device is connected to every other device. There are two types of mesh networks. Full mesh. Every device is connected to every other device. Partial mesh. Some devices are fully interconnected, while others are only connected to a few. Advantages. Redundancy. The most significant advantage of a mesh topology is its fault tolerance. Even if one connection fails, data can travel through alternate routes. High reliability. Since there are multiple paths for data to travel, the network is highly reliable. Disadvantages. Complexity. The more devices in the network, the more complex the cabling and configuration become. Cost. A full mesh requires a significant amount of cabling and hardware, making it expensive to implement and maintain. Use case mesh topology is ideal for critical networks where reliability and redundancy are essential, such as in military, telecommunications, or high-performance networks. Next, we have the tree topology, also known as a hierarchical topology. Tree topology is essentially a combination of bus and star topologies. It starts with a root node, which connects to one or more intermediate nodes in a branching structure. These intermediate nodes, in turn, connect to other devices. Advantages. Scalability. It's easier to expand the network by adding additional branches. Segmentation. It allows for easy segmentation of different network sections, which can improve network management. Disadvantages. Central point of failure. If the root node or any high-level node fails, the entire branch connected to it becomes isolated. Cabling costs. Similar to star topology, each device or node needs its own cable, increasing the cost. Use case tree topology is commonly used in large organizational networks and campus networks where hierarchical control and segmentation are needed. Lastly, we have the hybrid topology. Hybrid topology is a combination of two or more different topologies. For example, a network may use a star topology in one section of the network and a mesh topology in another section. Hybrid topologies are designed to take advantage of the strengths of each topology while mitigating their weaknesses. Advantages. Flexibility. Hybrid networks can be designed to meet the specific needs of an organization. Optimized performance. By using different topologies, hybrid networks can be more efficient and better suited for complex environments. Disadvantages. Complexity. The more topologies you combine, the more complex the network becomes, requiring more sophisticated management. Cost. Designing and maintaining a hybrid network can be expensive due to its complexity. Use case hybrid topology is used in large enterprise networks where multiple departments or divisions require different network designs, but they still need to be interconnected. Choosing the right network topology depends on several factors. 1. Cost. What's your budget for cabling and hardware? Simpler topologies like bus or ring may be more affordable, but they can lack scalability and reliability. 2. Scalability. How many devices will be in your network, and do you anticipate adding more? For future growth, a star or tree topology may offer more scalability. 3. Reliability. How important is fault tolerance and redundancy? If you need high availability, a mesh or hybrid topology might be best. 4. Performance. What kind of network traffic do you expect? For high-performance needs, reducing latency and data collisions is crucial. Star and mesh topologies are typically better for handling heavy traffic. 5. Ease of maintenance. How easy is it to troubleshoot and maintain the network? Centralized topologies like star make troubleshooting easier, whereas bus and ring topologies can be more difficult to manage. In summary, the topology you choose will significantly impact how your network performs, how scalable it is, and how easy it is to maintain. Understanding the different types of network topologies, bus, ring, star, mesh, tree, and hybrid, and their advantages and disadvantages will help you make an informed decision based on your needs. I hope this video helped clarify the various types of network topologies for you. If you have any questions, feel free to drop them in the comments below. And don't forget to like and subscribe for more educational content from TechCademy Labs.